Alright, let's talk about how to graph a tangent curve. First of all, remember the basic tangent graph. So this is I'm gonna do this one in red right here. The tangent of theta is the same as the sine over the cosine. So let's just look at these points. When x is 0, right here, so here's your x-axis and your y. When x is 0, meaning your 0 is my angle, the tangent is going to be the sine, which is your y-coordinate, 0, over the cosine, which is your x-coordinate. So when theta equals 0, the tangent of theta equals 0 over 1, which is 0. So 0 comma 0 is that point. Let's do this one right here, because that's easy. When theta equals pi over 4, so here's pi over 4 right here. When theta is pi over 4, what's the tangent? What's that divided by that? It's 1. Right? And when it's pi over 3, we're going to make this one right here pi over 2. Let's not even do pi over 3. When it's pi over 2, here's pi over 2 right here. What's 1 divided by 0?
Undefined.
It's undefined, and that's why your tangent graph is going to have a vertical asymptote wherever the cosine of theta equals 0. Wherever the cosine is 0, you're going to have a vertical asymptote because you can't divide by 0. So at negative pi over 2, you're going to have a vertical asymptote. This, at negative, or at 3 pi over 4, I should say, that's negative 1. And so what your graph's going to do, your graph is going to do this. That's one period. One period goes from negative pi over 2 to positive pi over 2, meaning one full period on a normal tangent graph is pi. And then it's going to repeat after that. So it's going to go, there's going to be another vertical asymptote right there, and it's going to go through that point, and through that point, and it's going to go like that, it's going to go like that, and it's going to repeat here as well. So that's your normal tangent graph, okay? So if my equation says something like this, I have to do the same thing where I take a look at my amplitude. That amplitude too just means it stretches it. It stretches my graph out. Instead of going, let's say this is my middle point, instead of going, the 0 is still going to be there, but instead of 1, 1, it's going to be 1, 2. So it's just going to stretch it a little bit more. Instead of, I shouldn't have said 1, 1. It's going to just stretch, it's going to stretch the graph. So the amplitude doesn't really do much that you can notice. And you can tell with the points it stretches it a little bit, but it doesn't change the asymptotes. This, again, it's the vertical shift. That your vertical shift now, instead of this point being at 0, 0, it's going to be 1, 2, 3, 4, 5, 6. It's going to be up there at that point, but it doesn't, I mean, it kind of does matter. But so your graph is going to be like this instead. It's going to be, the center point right there is going to be up 6. The amplitude just means it's a little bit more stretched. This means that it shifted 3 to the right. Now this is in radians because you see the pi over 4. So that's 3 radians to the right. So, and then this is the most important, one of the most important things. That b right there affects the period. So the period equals, instead of 2 pi over b, it equals 1 pi over b. So the period here in this case just equals 4. So let's write all of our information down here. The period equals 4. The a equals 2, which just stretches the graph a little bit. Doesn't really affect it too visibly. Oops. C, or the vertical C, equals 3, which means the horizontal shift is 3 to the right. And D equals 6, which means it goes up. The vertical shift is up 6. Alright, so let's see if we can graph that. So my normal graph would look like, fix that a little bit. Alright, my normal graph would have been at 0, but instead of being at 0, it's going to be at 0, 0, it's going to be shifted up 6. So it's we can sort of draw a horizontal line, not that that really matters like on the sine and cosine curve. But now what I'm going to do is I'm going to shift it, or I'm going to find the period, which is 4. So instead of going from negative pi over 2 to positive pi over 2, it's going to go from, there's that center point right there, it's going to go from negative 2 to positive 2. That's going to be one full period. But it's also going to be shifted 3 to the right. So instead of negative 2, I'm going to have to add 3 to this, and add 3 to this, and this was 0 here, I add 3 to that as well. So my points are going to be 1, 3, and 5. So again, I take that, I erase all that mess right there, and it's 1, 3, and 5, and so my vertical asymptotes are at 1 and 5, and then again 4 away from it. 1, 2, 3, 4. There's going to be another because the period is 4, and another 1, 2, 3, 4. There's going to be another vertical asymptote right there, and instead of being centered down here, it's centered up here at that line y equals 6. That's where that all-important point is right there. So all those points. Let me do this in black. All those points are in the center there. And furthermore, instead of going over 1 up 1, it's going over 1 up 2. That's the stretch that I was talking about, and over 1 down 2. So my graph looks like this. And that's the equation, or that's the graph, more than one period, but that's the graph represented by that equation right there.